Hello everyone, today our topic is about electronic configuration. Okay, configuration means arrangement. Configuration means arrangement. Okay, arrangement of electrons in shells, in atom shells. Okay, so here we are going to study and discuss that how the electrons are being arranged properly in shells. So before explaining electronic configuration, I would like to remind you somehow about the postulates of Bohr's atomic model. Okay, so Bohr's atomic model, the principles or the postulates that he had given at that time, it was about that atom consists of shells. Okay, atom have shells, and sometimes it's also called quantum shells. Okay, another terminology which is used for shells is quantum shells. And this shells, each cell represent energy. Each shell represents energy levels of electrons within an atom. Okay, is that clear? So the shells, they are actually these shells. These are actually the energy levels of electrons. Okay, is that clear? The third postulate of this says that shells nearest to the nucleus have lowest energy, and that's why these shells which are nearest to the shell, they are called lowest energy levels. Okay, and so shells further away from nucleus have higher energy. Okay, and that's why they are called high energy levels. High energy levels, or sometimes called shells. Okay, so if you see, this is an atom. Okay, suppose an atom X. Okay, so these shells, if I draw the shells like this, and this is the nucleus plus, because nucleus have plus positive sign, so each shell represent the energy level. The first shell, which is called the K shell, it will have the lowest energy. Electrons in this shell, it will have the lowest energy. The next shell, which is called the L shell, it will have a comparatively higher energy as compared to electrons which are in the K shell. Is that clear? So electrons which are in the L shell, they will have highest energy as compared to the first shell. Let's suppose this is the M shell, and its energy would be higher as compared to L shell and K shell. Okay, and so if the shells are increasing, okay, the energy of the electrons will also get increased. Okay, so shells which are further away from the nucleus, those shells which are further away from the nucleus, they have higher energy, and those shells which are nearest or which are nearer to the nucleus, they have lower energy. Okay, now this is the basic arrangement of electrons in terms of energy level. Keep in mind that if electrons want to jump or move from higher energy level to lower energy level, from higher energy level to lower energy, what will happen? That in this case the electron would release energy. I will repeat, if electrons move from higher energy level or from higher shell to lower shell, what will happen? Electron will emit energy, and this electron will emit energy in the form of radiations. Okay, is that clear? In the same way, if electrons want to move from lower energy level to higher energy level, what will happen? Electrons need to gain energy. Electrons need to gain energy, and when electrons gained energy, they will get excited, and after excitement they will move towards higher energy level. Is that clear? So let me write this, that if electrons move or shifts or transfers from higher energy level to lower energy level, okay, what will happen? Energy will be emitted from electrons. Is that clear? In the same case, if electrons transfer from lower energy level or from lower shell, okay, what will happen? Electrons will need to absorb energy and resultantly get excited, and what will happen? The result will get excited, and they will transfer to higher energy level or shells. Now coming towards our main topic is that electronic configuration. Okay, electronic configuration, or simply we can this can be defined as the arrangement of electrons in an atom shells or energy levels. Okay, now this electronic configuration, there is a very basic rule. The rule for that, the theoretical rule, or there is a rule for arrangement of electron. The rule for this is 2n square. Okay, this is mathematical rule. This rule, it can be applied for the arrangement of electrons in the first, second, third, and so energy levels. Okay, here this n represents shells. Okay, now for example, and it starts from 1, 2, 3, 4, and so on. It starts from 1, not 0. Keep in mind. Okay, now let's suppose, for example, there is for example carbon 6. Okay, so here in the first shell it is 2 and the last shell 4. So how do I know that in the first shell there are 2 electrons, or in the second shell 4? So we will take help from this mathematical rule. Okay, now for example of first Fourth shell, okay, so 2 and 1 square, okay, and where n represents the shell, number of shells, starts from 1, 2, and that's all, okay. So here 2 into 1 is equal to 2 electrons. So in the first shell, maximum 2 electrons can accommodate, maximum. In the second shell, the maximum number of electrons that can accommodate it is 2 to 4, 4 to 8 electrons, okay. The maximum number of electrons in the second shell, it should be 8. Lesser than 8 is possible, but higher than 8 is not possible. In the third shell, okay, third shell, 2 n, here n is 3 square, 2 into 9, that is 18 electrons. So in the third shell, maximum 18 electron can be placed or can accommodate. In the same case, in the fourth shell, the maximum number in the fourth shell, it would be 2, 4 square, 2 into 16, that is 32 electrons, okay. In the fifth shell, 2, 5 square, 2 into 25, it is almost 50 electrons, okay. In the sixth shell, there are 2, 6, 32, and here 2 to 4, 64 electrons, okay. So in the sixth shell, maximum 4 electrons can accommodate. Keep in mind that this is actually the rule for the accommodation, okay. This rule, this 2n square, this rule is only for accommodation. Accommodation means placement. Accommodation of maximum number of electrons within any shell. It means that, for example, sixth shell, there can be lesser than 64 electrons in this shell, but higher than 64 is not possible. Is that clear? In the same fifth shell can accommodate or can tolerate 50 electrons, not more than that. Lesser than that is possible. In the same case, fourth shell can accommodate or can tolerate or have the patience for 32 electrons. Lesser than 32 electrons is possible in fourth shell, but higher than 32 electrons is not possible, okay. So let's do some examples related to this rule, okay. Now, for example, nitrogen atomic number is 7, okay. Atomic number means that there are 7 electrons in nitrogen. So the electronic configuration would be 2 minus 7, 5. So nitrogen have 2 shells and electronic configuration is 2, okay. And arrangement of the electron, you can draw proton. How many? 5 proton, okay, 5 proton, 7 proton over here, and 7 neutron, and 2 shells are there, okay. So 1 electron, 2 electrons in the first shell, and 5 electrons, 1, 2, 3, 4, 5 electrons in the second shell. In the same case, for example, boron atomic number is 5, okay. So electronic configuration would be 2. In the first shell, 2 minus 5, the remaining electrons would be 3. So in the same case, nucleus, fourth shell, second shell. First shell can accommodate 2 electrons, the remaining electrons in the third shell, 1, 2, 3. Is that clear? Let's do another example. For example, fluorine. Fluorine atomic number is 9. Electronic configuration would be 2, 8. 8 plus 2. A second shell can accommodate 8 electrons, okay, as we have calculated earlier. So 2, 8, 8, 9, 10. It would be 2, 7. Sorry, 2, 7. Okay. So nucleus, first shell 2 electrons, and the rest of the 7, 1, 2, 3, 4, 5, 6, 7. In the same case, neon atomic number is 10, so its electronic configuration will be 2, 8. The second shell is complete. So nucleus, first shell 2 electron, second shell 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Is that clear? So another example, chlorine. Chlorine atomic number is 17. Okay, so its electronic configuration would be in the first shell 2, second shell 8. 8 plus 2, 10. Okay, then the remaining 7, 8, 10, 7. Third shell contains 7 electrons. So you will draw nucleus. The 3 shells are there. 1, 2, and 3. Is that clear? So the first shell 2 electrons, second 8, and the last shell contains 7 electrons. Okay, is that clear? So this is how you can practice electronic configuration and draw the atomic structure of various elements. In the same case, for example, magnesium atomic number is 12. Okay, so electronic configuration will be 2, 8, 2. Okay, 2, 8, 2. So it's a is that clear? So in the nucleus we know that 12 protons are there. Okay, so first shell consists of 2 electrons, second as usual 8 electrons, and the remaining 2 electrons in the last shell. Is that clear? In the same case, there is another metal, calcium. Calcium atomic number is 20. Electronic configuration will be 2, 8, 2. Yes. Okay, so in the third shell there is 8 electrons. How this is possible? We have said that maximum number of electrons in the third shell is up to, it should be more than 8 electrons, but I told you earlier that it can be less than the maximum number of electrons but not greater than the limit. Okay, so we know that in the third shell the maximum number of electrons in the third shell, it can be 18 electrons, but here 8 electrons. So again I would repeat that 18 electron is the maximum number of electrons in the third shell. It's a limit. This 2 n squared specify the number. It shows it gives limitation. Limit number of electrons. Lesser than this is possible, but greater than this is not possible. It means the third shell can accommodate lesser electrons, lesser than 18 electrons, but not greater than 18 electrons. Okay, so now let's draw the structure of the calcium. Calcium is in fourth period. 2 electrons in the first shell. The second shell have 8 electrons. Okay, and then third shell also have the 8 electrons, and the valence shell or the last shell is also called valence shell. The valence shell is also called last shell. It have 2 electrons. Okay, and keep in mind that those electrons which are present in the valence shell, these are called valence shell electrons or valence electrons. Valence electrons are those present which are present in the last shell or last energy level. Okay, so this is how you can draw the structure of the atoms according to the 2n square, rule. Okay, again I would like to repeat that this 2n square is only a rule to limit the number of electrons with any energy level.